Okay, I'm making this video for anyone that may be absent or wanted to hear the lesson again. I'm trying to be fast but concise. Okay, so, or fast but thorough. How about that? So we're looking at some of these advanced trig formulas. So we have the sum and difference formulas, the double angle formulas, and the half angle formulas. And I plan to give you all of these on the test. So this is in the header. I squished it up a little bit, but that's the header of your test. So be aware, we can't just say, okay, so sine of 30 degrees is 1/2, and sine of 60 degrees is, that's degrees, is √3/2, and sine of 90 degrees is equal to 1. All of this, if you don't know from the unit circle, it's time to go back and make sure you own the unit circle. But notice, if I were to say sine of 30 degrees plus 60 degrees, I can't distribute that sine through. So notice 30 plus 60 is 90. Well, you can't add these two and get 1. Okay, so we can't, this is definitely, absolutely not equal to sine of 30 plus sine of 60. What we can use instead, it just makes me shudder to even write that. What we'll use instead is that sine of an angle plus another angle is equal to sine of u cosine v plus cosine u sine v. Now the minus, if you have a minus in here, you'd have a minus in there. So the top goes with the top, the bottom goes with the bottom. And this one I just remember sine, cosine, cosine, sine, and it's the same SIGN. So this SIGN is the same between those. The cosine rule, the cosine sum and difference formula, cosine u plus v is cosine, cosine, sine, sine is how I remember that. And it's the opposite SIGN. So this one, if it's a plus here, it's a minus there. If it's a minus here, it's a plus there. You'll have these formulas, but I just remember sine, cosine, cosine, sine, and then cosine, cosine, sine, sine. The SINE has the same SIGN. Okay, I'm moving on. And then there's tangent, where tangent of u plus or minus v. It's the same SIGN up here, and it's the opposite down below. So tangent of u plus tangent of v over 1 minus tangent of u times tangent of v. And then what we can do is, if we have, in this formula I'm using 2u, I can remember that sine, well, 2u is the same thing as saying u plus u. And then I can come back up here and use this formula, and then all of these angles are u when I have u plus u, and so that gives me one sine u cosine u and another sine u cosine u, and that's where we get this formula. So sine of 2u is equal to 2 sine u cosine u. The cosine, we did the same idea. This would be like saying cosine of u plus u. So we come back to this equation, and instead of having v's, we now have a u and a u, so it's cosine u, sine u, which is how we get cosine squared minus sine squared. Then I used the big daddy. I substituted, I used the fact that cosine squared u is equal to 1 minus sine squared. And I used the fact that sine squared is equal to 1 minus cosine squared. So we nicknamed that the big daddy, and I plugged that into this first equation to clean it up to get to the other two. So if you weren't in class, pause a moment, plug it in, and see what happens. Then we manipulate, basically we manipulate these two, where this is cosine of 2u and cosine of 2u. I can manipulate these to get to the half angle formulas. So what we do with that is we say, well, I'm using u. In class I used a, but same idea. Oh, you know what? I don't want to use u and u here. Let me change this. Let's use a and x. So we're going to say let x equal, I lied, let a equal x over 2, so therefore 2a is equal to x. So what I can do is I can say, well, cosine of 2a, which I'm using this formula here, is equal to 2 cosine squared a minus 1. 2a is equal to x. A is equal to x over 2. and then minus 1. So I can solve this for cosine of x over 2 by saying cosine of x plus 1 over 2 is equal to cosine squared of x over 2. And here's where, in my classroom, we joke about the cheer, the square root, plus minus. And we do put a plus or minus in the formula, but the thing that you have to consider is where does this angle actually live? Because it's not going to be both plus and minus. It's going to be plus or minus, but the equation won't tell you. You have to figure it out. So when I clean this up, we take the square root of both sides and we go from here to here. So then the sine is using the same stuff over here, except we're going to use the second equation. Cosine of 2u equals 1 minus 2 sine squared u. Oh, I wanted a's. Cosine of 2a is equal to 1 minus 2 sine squared of a. I can replace 2a as x. And then I'm going to do the same thing I did. I'm going to subtract 1, divide by negative 2. Oh, what am I doing? Subtract, well, it ends up becoming this over a positive 2. Hopefully that makes sense to you. That's sine squared of x over 2. I subtract 1, and then when I factor out a negative, the 1 becomes positive, the cosine becomes negative, and then it'll cancel with this negative there. And then take the square root of both sides, and I end up getting this. So the way that we use these is they may give you something. By they, I mean me. Haha. Just kidding. Okay, so I may say something like, find cosine of 5 pi over 12. Okay, so we've got a few different options. What we can do is we can one way that we can do this is we could say, well, this is equal to 3 pi over 12 plus 2 pi over 12, because 3 plus 2 is 5. Well, and this cleans up to be pi over 4 plus pi over 6, and these are both things we know from the unit circle. So then I can do, this is my cosine rule, so it's cosine, cosine, sine, sine. Cosine, cosine, sine, sine, and then I do the opposite SIGN, so instead of that it's now a negative. And then I'm back in my world of the unit circle. Cosine, it is a Friday afternoon and I am tired, so if I make mistakes, well, it happens. That's a half. Okay, and this cleans up to root 6 over 4 minus root 2 over 4, which is a fine way to leave it. If you want to say this, I'd take either of those. The other option is to recognize that 5 pi over 12 is equal to half of 5 pi over 6. Okay, so what happens with that one is that you can say cosine of 5 pi over 6 over 2 is the same thing as the cosine of 5 pi over 6. Now this is going to use a totally different formula, and the answer will look very different, which is why sometimes I have you find a decimal approximation. This formula, my half angle ones are not something I have memorized. 1 plus cosine, okay. So it's the square root of 1 plus cosine of 5 pi over 6 over 2. Now before I continue, we got to think about, with this one, we have to decide, is it going to be plus or minus? And in step 1, I'd encourage you to put either plus or minus. The minus you have to. The plus you don't have to, but that will remind you that you've already thought about it. Okay? So when I think about my unit circle, I have here 0, I have pi over 2. Well, pi over 2 is 6 pi over 12. Okay, so since this one was 5 pi over 12, I'm going to be somewhere in here. So my sine will be positive and my cosine will be positive. So cosine here is positive, so I'm going to just write down that plus sign to remind me that I've taken care of it. And now I have the square root of 1 plus, well, cosine of 5 pi over 6 is a negative root 3 over 2 divided by 2. Well, you can't leave fractions in a fraction, and really I don't want you to leave fractions under the radical. So I would come through, there's many ways to clean this up, but here's one. I distribute the 2 through. This becomes the square root of 2 minus root 3 all over 4 The 4 is still under the radical, but we're about to bring it out. We can say the square root of 2 minus root 3 all over 2. And there is a way to manipulate. Okay, so we got this answer, and we got these answers. Well, they're the same. For the same cosine of 5 pi over 12. Well, this one looks kind of screwy. It looks kind of weird. But if we grab a calculator, I don't know what I've been doing. Okay, where was I? I have the square root of 2 minus the square root of 3 over all over 2. Notice that cleaned up. The calculator knows how to rationalize that sort of stuff. I've seen it, it's cool, but it's not really worth our time in this particular course. So if you got to this answer, you could stop here. So in my answer key, I'm likely to use to include both of these values. So make sure you can get there. The other thing, that's how we use some of those formulas. The other thing that we might see with some frequency is I might tell you something like that sine of A is equal to, I keep using 3, 4, 5 triangles. Let's do a 12, 13. Sine of A is negative 12 over 13, and pi is, I'm making this up as I go, less than A, which is less than 3 pi over 2. So A is in quadrant 3. And let's say, so I'm going to just go ahead and say, all right, well, here we go. We're in quadrant 3. The sine is the opposite. That's a negative over the hypotenuse. So therefore, this is a 5, 12, 13 triangle. That's also in the negative direction. So we know that cosine of A is negative 5 over 13. And we know tangent of A, this should be old hat. You should be good at this. It's 12 over 5. Let's say they also give you that cosine of B is equal to, let's not make it pretty, 1/5. And it's in quadrant, well, 4. Let's say 4. 3 pi over 2 is less than B is less than 2 pi. That puts us in quadrant 4. Once again, making it up as I go. So this is the adjacent, not to scale. I don't really care over the hypotenuse. This becomes a negative root. 25 minus 1 is 24, which is negative 2 root 6. Hopefully I'm right. Okay, and so then I can say, well, sine of B is equal to negative 2 root 6 over 5. Tangent of B is a negative 2 root 6 over 1. Well, that's lovely. So it's just negative 2 root 6. And then let's say, so they've given us these two scenarios, and then they might ask us all sorts of things. They could say, okay, what's tangent of 2B? Or not 2B. Okay, or they might say, what is cosine of A minus B? Or they might say, what is, I mean, we could do whatever. Tangent of adding the two angles or subtracting the two angles. Basically, we could use any of these formulas. I could say, what is the sine value of A over 2? Okay, so if whatever they ask me for, we can use the formulas that we've gotten over here to manipulate and to use this information that we have. So I always write down all of this stuff kind of as my, well, as the resources I need to answer whatever question they might ask. So say they do tangent of 2b, then that's 2 tangent b over 1 minus tangent squared of b. So, sorry, I had a knock at the door. And so this is 2 times tangent of b. We just said, oh, this one's going to clean up nicely. And then over 1 minus a negative 2 root 6 squared, which becomes a negative 4 root 6 over 1 minus, well, that's 4 times 6 is 24. Okay, so something like that. Negative 4 root 6 over negative 23. Oops, they cancel. It's positive. I could do any other one using those formulas. Let's do, well, let's just call it a day. This is long enough. Hopefully that's helpful. Practice. It makes a difference if you practice. And then these will also show up in proofs. So don't just stop with these equations. Make sure you try all sorts of things. Enjoy.